So now, some advanced instruction for smart automation, and these instructions are normally used for programming of PLC. So first of all, outline for today's session. We are going to discuss the timers, how timers can be used in our ladder diagrams to program the PLCs. Then we will discuss counters, and we are going to discuss the basically need of timers and counters in our process control. Then we will have some examples on timers and counters using LADSIM. First of all, we are going to program using LADSIM, and we will use timers and counters there. Then we will see how to use timers and counters and how to program them in RS logics. So exposure of both the softwares will be given to all the participants. Then we are going to conclude, and then some references. So first of all, timers. Basically, the PLC must be able to perform counting and timing operations, right? Each and every PLC, they should be able to perform these counting and timing operations. And for this purpose, each and every PLC manufacturer, they provide counters and timers, and these can be programmed by the programmer to you can say control any process, to automate anything. So these can be used. Now, so PLCs have timers and counters, and that can be programmed into ladder diagram. Now, basically, timer is essentially an internal clock that counts in intervals of 0.1 seconds. It is not always 0.1 second. Here, just I'm giving one example. It is 0.1 second. In some PLCs, they provide internal clock of 1 second. In some PLCs, they provide internal clock of 0.1 second. Some PLCs, they provide this internal clock of 0.01 second, right? And some PLCs provide the option. They can provide all the three options, whether you want to go for 1 second internal clock, you want to go for 0.1 second, you want to go for 0.01 second. So depending upon your basically requirement, you have to set this internal clock. Means with timer, that I will explain when we are going to start the working of timers. There I will explain means what is the purpose of using internal clock of 1 second, internal clock of 0.1 second, and internal clock of 0.01 second. Now, different types of timer. Basically, there are two types of timers. First is on delay timer, and the second is your off delay timer. So, as I told you, timers are used to provide the timing delay. Let us say if you want to make something on after some time, so you are going to set the timer, and after that time, that particular output will be on. Or maybe you want to make something off after that particular time. You have to basically set the time in the timer, and you will be able to basically make some output off, right? So whenever we are going for timers, some parameters will be there, and you have to basically program these parameters in order to use the timer in your ladder diagram to control the process. There are several parameters associated with timers instructions, and those parameters can be accumulated value, it can be preset value, it can be time based, it can be timer accuracy, right? So normally these timers, they contain these three things: accumulated value, preset value, and time based. Now we will see what do you mean by these different three parameters. First is your accumulator value. Basically, accumulator value is the time elapsed since the timer was last reset and when enabled, the timer updates this continually. Basically, accumulator value will increment by the time base selected by you, and it will continually it will update until it reach the required value, right? So that is the accumulator value. Then preset value. Preset value is the value that a timer must reach before it sets the done bit of the timer. So timer, they have done bit. Let us say you want to give a 4-second delay, then your preset value will be 4. And for example, we can take one example. We want to start a conveyor after 4 seconds, right? So in that case, what we will do, we will set the preset value as 4, and our time base will be 1. And time base here 1 means our internal clock, it will increment by 1 after 1 second. Time base is this. And after when our this accumulator value, it reaches 4, means it is equal to or greater than preset value, then your timer done bit will be set, and that timer output, or you can say I am here, I am just in technical terms, I am saying it is done bit, or you can say that some output will be high, and that output can be used to make any physical output high. It can be conveyor, it can be wall, anything. So preset value is the value basically which is required, means whatever delay is required, that will be set using this preset value. So here you can see that already explained, when the accumulated value becomes equal to or greater than the preset value, then your done bit output will be high. Now we can use this output to make anything on or to make anything off, depending upon what kind of input we are using, whether we are using XIC, that is examine if closed, or we are using XIO, examine if open. So depending upon that, your output will be either on or it will be off. Now, same thing. Now we can use this done bit to control an output device. Now, this is very important, time base and timer accuracy. Basically, as I told you, internal clock of PLC, it can be of 1 second, it can be of 0.1 second, it can be of 0.01 second. So means depending upon the selection of time base, whether you are selecting 0.01, you are selecting 0.1, or you are selecting 1, your accuracy of timer will depend. Now I will take one example here. As I told you, there may be option in PLC, either you can select any one of these 3 values, or your PLC is going to provide a timer internal clock of 0.1 second, or they may provide you internal clock of 0.01 second, or it may be 1 second. So actually, in nutshell, if we take the time base as 0.01 second, हेलो, हाँ जी प्रोफेसर, थैंक यू, मैं करना, मेरा लेक्चर चल रहा है, फिर मैं कॉल करना, ठीक है, राइट, थैंक यू. So now I will take one example. Let us say in bottling plant, just take one example of bottling plant, whether it is Coke, Pepsi, any bottling plant, it can be there. So our bottle, basically it is moving on the conveyor, right? Our sensor is detecting the bottle. Now means our photo sensors will be there, they will detect the bottle. Then after detection, that bottle will move from the sensor to filling station, right? Sensor to filling station, let us say it reaches there in 5 seconds, right? Means it reaches the exact position in 5 seconds. So in that case, we can select time base as 1 second, right? We can select time base as 1 second, and after your accumulator value, it reaches 5. It is equal to 5, or you can say more than 5, then our output will be high, and it will open the valve of the filling station to fill that bottle, right? Now, uh, second example is, now that bottle is taking 5.4 seconds time to reach that particular spot, or to reach that filling station, right? So if we take this time base as 1, right, then in that case, either I can select my preset value as 5, or I can select my preset value as 6, right? Because my internal clock, it will increment by 1. I don't have any other option. Either my preset value will be 5, or it will be 6. If I select my preset value as 5, then my bottle will stop before reaching the filling station, because the actual time delay is 5.4. If I select preset value 6, in that case, my bottle, it will pass the filling station and it will stop after crossing the filling station. So basically, my bottle, it will not stop where filling station is there. So you can say that accurately it should be there below the filling station. What is the option in that case? In that case, we are going to select the time base as zero point 0.1 second, right? If my time base is zero point 0.1 second, so in that case, my internal clock is going to increment by zero point 0.1 second. And what will be our preset value? In that case, my preset value will be 54. 54 multiplied by zero point 0.1 is equal to your 5.4 second. Now you can see the accuracy point here. So when I give preset value as 54 and my internal clock is selected as zero point 0.1 second, my that bottle, it will stop exactly below the filling station for filling the bottle, right? This is the second example. So the next example is, now take third case. uh, Bottle is taking time to reach the filling station. Let us say it is taking 5.45 seconds to reach the filling station. What will happen this, if I take this time base as zero point 0.1, then either I can give preset value as 54, or I can give my preset value as 55, right? If it is 54, then bottle will stop at 5.4 after 5.4 seconds, but my actual requirement is 5.45. So it means that before reaching this filling station, bottle will stop. If I give 5.5, then bottle will cross the filling station and it will stop after passing the filling station. Again, we need more accuracy. So in that case, what we will do, we will use time base as zero point zero 0.01 second, right? And my preset value will be 545. 545 multiplied by zero point zero 0.01, and it will be equal to what? It will be equal to 5.45. So my, if I select this time base, that is 0 0.01, my bottle, it will stop exactly at the same point where my filling station is there. So now from here, I think everyone can understand what is the purpose of this time base, and how this time base is related with accuracy of your timer. So in nutshell, we can say that if we, for safer side, if we give select time base as zero point zero 0.01 second, it will give more accuracy. Point 0.1 time base, it will be less accurate as compared to zero point zero 0.01 second. but it will be more accurate as compared to 1 second. And 1 second, if we take, then it will be less accurate as compared to zero point 0.1 and 0.01. So in this way, basically, depending upon your time delay, depending upon your requirement, depending upon your you can say application, we have to select the time base. So I think now it is clear, these three parameters: accumulator value that will increment by 1 after internal clock, and preset value is the required delay. There you have to set the value whatever delay is required. And time base is the basically you can say selection of internal clock, means after how much time your internal clock will be incremented by 1. So these three parameters are there, and we are going to use these three parameters to program our timers. So just keep these things in your mind, how to program it. Now we will go for the timer. This timer is basically related to RS Logic software, right? So this is T on timer, timer on delay. So timer on delay, you can see that its symbol is T on. From here you can see this is T on. And what is this T4 colons 0? Basically, file number 4 is related to timers. All the timers are there in this file in T4. So if it is and there are around 255 256 timers are there, starting from T4 colon 0 to 255, and you can program any timer out of these. Second, you can see that time base. I have already explained to all of you that time base is your what? This is the timer address T4 colon 0. Time base is your internal clock selection, means your internal clock will increment after each 0.01 second. Preset is the value you can say for which you want the delay in making anything, any output on or off. So actual how much delay you will get, 120 multiplied by 0.01 second, it is equal to 1.2 second delay. Now your accumulator will increment by 1. Here initially it is 0, it is reset to 0. Now it will increment by 1 after 0.01 second, and when it will be equal to or greater than preset value, that is 120, then your this bit will be high, and we can use this bit to make anything on or off in our process. So after 1.2 second delay, if you want to make any conveyor on, if you want to make any valve, you want to make a valve open after 1.2 seconds, and you want to stop the conveyor, so all those things you can do with this. So now just take that example of a bottling plant. We have two outputs. One is conveyor, second is your filling station valve, right? So in this case, after 1.2 seconds, your conveyor should be stopped, so that your bottle will be there below the filling station, and your valve of that filling station will be on. It will be open to fill the bottle. So basically with this timer, we are stopping the conveyor, and we are basically uh, opening the valve of filling station to fill the bottle. In this way, we can relate this timer with your that particular example. So here now you can see that I have explained the working of timer in just layman language. Now in technical terms, you can see. So here we can see that use the T on instruction to turn an output on or off after the timer has been on for a preset timer interval. So you can see that after preset value, when your accumulator value is equal to preset value, then we can make any output on or off. Now, same thing I have already explained. Now, in technical terms, it is T on instruction begins to count time-based intervals when run conditions become true. Run condition becomes true means when we are sensing any signal, when bottle is crossing the sensor. As long as run condition remain true, the timer adjusts its accumulator value um with each evaluation until it reaches the preset value. Now your accumulator value will increment by 1 depending upon the time base. Now the accumulated value is reset when run condition go false. So basically whatever input is connected with your timer, if it is on, then your timer will work. It will work. Your accumulator will increment by 0.01 second after interval. When we make that input off, then your timer will be reset. Means whatever input is connected with your timer, if you make it off, then your timer will be reset and your accumulator value will go to 0 again. So it will not see whether the operation was complete or not. If that input is off, then it will it will reset the accumulator value to 0, and regardless of whether the timer has timed out, we have to take care of this thing. Then next is timer off delay. Two type of timers are there. First is timer on delay. Second is timer off delay. Here you can see that same thing. Uh, we denote is with TO off. TO off is the basically symbol, and this is the symbol for timer. This is the address of timer instruction, that is T4 colon 1. This is the address of timer instruction T4 colon 1. Then time base is 0.01, right? Same, and preset value is 1.2. Now accumulator value is 0. Your this done bit will be set after 1.2 seconds. So use this T off instruction to turn an output on or off after its run has been off for preset time interval. So basically when you will make a true to false transition, in that case this timer is going to work. In earlier case, your run, now here you can see that in earlier case this timer is going to work when the input is high, but in this case your timer will work when you will make your input on and off. So one on and off transition will activate the timer. After that, it will start its working. So this is the meaning here. You can see that T off instruction begins to count time-based interval when the run makes a true to false transition. Here, true to false means on to off transition. On to off transition of the switch, whatever input is connected with this timer. Now, as long as your input switch is off, the the timer increments it accumulated value based on the time base of each scan until it reaches the preset value. Now, in this case, the accumulator value will be reset when run condition go true again. So it will work from on to off, and once you make that input on, at that time your timer will be reset and it will reach 0 regardless whether the timer has timed out or not. Or here you can see that whether timer has completed its work or not. If we make you can say off to on transition, then your timer will be reset to 0. So these things we have to keep in mind. T on timer will work if our run condition is on, if our input is on, and T off timer will work if our input is making a transition from on to off. These things you have to keep in your mind. Next is your retentive timer. Now I will explain the difference between T on, T off, and this RTO timer. RTO stands for retentive timer, and this is the symbol for this RTO timer. So first of all, we should be very clear, means where to use this T on timer, T off timer, and where to use this RTO, right? Okay, we can continue with that example only, bottling plant. Let us say our bottle is moving. Now bottle is stopped at the filling station. So when bottle is stopped, here basically the difference is, in case of your this T on timer. Just we can take this example, T on timer. If your input goes off, that timer will work when input is high or on. If your input goes off, then your accumulator will reset, and next time when you make that input high, again your timer will start from zero, right? In retentive timer retain its accumulator value if your input is become off. From on to off, it will retain its value, and when again you make it on, it will start its working from that accumulator value only. It will not reset to zero. Let us say when my accumulator value reaches 45, right, and there is a power failure. In that case, our input will be off, but our accumulator will retain its value at 45. Whenever power is there, it will start its working from 45 onwards. It will count from 46, 47, like that, RTO. But T on, it will again start its working from zero. Now we will see the example where T on is suitable, where T off is suitable, right? For example, in bottling plant, bottle is moving and it reaches the filling station. Um, uh, Reaching the filling station, and let us say our bottle, it takes say um, 4 second or 4.5 second to fill that bottle, right? Now once our bottle it reaches the filling station, and our bottle is partially filled, let us say for 2.3 seconds, and at that time power goes off, right? At that time power goes off. In that case, if I am using T on, right, just consider here, if T on is used, then if power comes, then it will start the filling of bottle again from zero. It will not see bottle is already filled, partially filled for 2.3 seconds earlier. It will start from zero. In that case, that drink, it will overflow from the bottle. So in that case, your T on timer is not successful. So if I use retentive timer instead of that T on timer in this application, what will happen? Let us say bottle is filled for 2.3 seconds and power goes off. So it means that your preset value reaches 23, or maybe it reaches 230, right? So what will happen? Sorry, your accumulator value reaches 230 or 23. In that case, when power goes off, in case of retentive timer, accumulator value will be retained as 23. Whenever power will come, means partially bottle is filled. Whenever power is coming, in that case, it will start filling the bottle from that point only. Means for 2.3 second bottle is already filled, it will start for 2.4 second, and it will start filling from there, and it will fill the bottle, and there will be no overflow. It will start the same value where the process was stopped. where that accumulator was present. So this is the basic difference between T on timer and retentive timer. So depending upon our application, we have to select RTO or we have to select T on, depending upon these. Rest is same. Yes, resetting is different for retentive timer as compared to T on. Now, and this was the basically justification of RTO timer as compared to T on, and how it works in actual now technical terms. So here you can see that RTO instruction is basically it is used to turn an output on or off after this timer has been on for a preset time interval. Again, it is going to work when your input is on, right? If you make that input off, then accumulator will not be reset, it will retain its value. Now RTO instruction is retentive instruction, you can see, and that begins to count a time based intervals when run condition is true. True here means when your input is on. Now RTO instruction retain its accumulated value when any of the following occurs. As I told you, if you make that input on to off, this is the first point. Run condition becomes false means your input becomes off. When you change processor, now you are very well aware, we have different modes. Run mode is there, program mode is there in RS logics, then test mode is also there. So whenever you change the processor operation from run mode or test mode to the program mode, again it will retain its value, accumulator will retain its value. This example I have already told you. If processor loses the power, there is a power failure. Mm, uh, but in most of the conditions, we have battery backup. Sometimes that battery backup is also not sufficient. In that case, you can lose the power of your processor. In that case also, our accumulator value should be retained, right? And the next, if any fault occurs, maybe some technical fault, maybe some you can say connection fault, in that case also you have your accumulator should retain its value. So there may be different conditions where basically you have to make this accumulator to retain the values, right? So now these three type of timers are there: T on, T off, and RTO. Now we are going to see the working of these timers, how these timers are going to work. Just give me 2 minutes, please. Okay, sorry for interruption. Now we will see the working. We will see the working of these instructions on both the softwares. First, we will see it's working on LADSIM software, how our timer works. LADSIM. Please just concentrate because today's practice session will be based on timers and counters only. Just watch these videos carefully. Now, first, how to use timers using LAD sim, and that is also expected from all the participants. They should know and they should learn so that they can easily perform the practical tasks on this LAD sim. Now, open the LAD sim window. I am taking one instruction, XIC. Now we have to select the timers. This is the timer. Select, give address, and give the preset value. Preset value is means the time delay that you want from the timer. This is basically on delay timer. Add rung. Take one more input. Give timer done bit address. So this is the T1 oblique DN. This is the address for timer done bit. And we can make any output on. So now go to run mode. After 3 seconds, this output should be on. You can see here, you can see the accumulator value is increasing, and after reaching 3, your output is on. So when I make this off, again your timer is reset. Again, when I will make it on, now here you can see that accumulator value is increasing. After reaching 3, your output is on this. So here we are providing a delay of 3 seconds to make our output on and off. Now we are extending this program further. I'm using one more XIC instruction in rung 2. Again, I'm using timer done bit. I'm taking one more timer. Again, I'm selecting preset value as 3. Okay. Then now I will automatically reset first timer using done bit of second timer. This one. Now, why we are using this thing? By using this thing, now I will make this. Now I will use one. I will make this output on and off after 3 seconds continuously. Now you will see after 3 seconds it is on. Now second timer is on. After 3 seconds it is off. Again after 3 seconds it is on. After 3 seconds it is off. So now it is continuous. We are using 2 timers, and our input, you can see that this output, it is on for 3 seconds, it is off for 3 seconds, and continuously it is moving. So this is the basically working of. Hello. Yes. Hello. नमस्ते नमस्ते की हाल है अजय अजय लेक्चर चल रहा है मेरा लेक्चर ठीक है मैं बात करूँ ठीक है So now we are going to see the working of timers on RS logics. So in RS logics, now timer. So how to program this timer in RS Logics? Now here you can see that same instruction, whatever. Select the same micrologics. Now take one XIC instruction. Now we are using the timer. Here you can see that first this is T on timer. Again we are taking one input, we are taking one output is here. Now give the address. Address is I colon 0 by 1. Now give the address to timer. As I told you, T4 file is for timer. Then it is T4 colon any timer from 0 to 255. So here now you can see that time base. Time base is of 1 second at present. But you have the option, either you can select 0.1 second or you can select 0.01 second. Here I am giving the delay of 2 seconds by giving preset value of 2. Now you have to use a done bit of timer T4 colon 1 by DN. This is the address for done bit of timer. And whatever output you want to control, you can give that address O colon 0 by 1. Right. So it is same program just like let's see. Now how only the difference is its addressing. Now we will see the working. We can now verify the project. There are no errors. Now we can save it to any location on your PC. Now it is saved. We can go to the download. We download this program to your emulator. Now you can see the rotation of logo. Now go to run mode. Yes. So now just make this input high in order to start the working of timer. Now your timer has started its working, and after 2 seconds your output is high. Make it off and again make it on. Now you can see, now again after 2 seconds your output is high. So when you make this input off, then your timer value will be reset. So this is the working of your timer in RS Logics. And now we will see how that program will work continuously, on and off program. This is just extension of that only. I am going to use one more XIC. Again we are using same done bit. We are going to use another timer, second timer. Again we will give preset value of 2. It can be T4 colon 2, right? Time base again we are selecting as 1 and preset value is 2. Now we will use done bit of this one to reset the timer in this yes, T4 colon 2 by DN. Just make it 2. Project verification is complete. Now so we save this project. So now go to run mode. Now make it on, and you will see your output will be on for 2 seconds, and it will be off for 2 seconds. On, off. Now it is continuous process, on and off. So in this way, we can basically use these timers in both softwares, in LADSIM as well as in our this one RS Logics. So I think now with this, everyone is clear about the working of timer. Now next we will go to the counters. This part is done. Now counters. Here you can see that counters are similar to timers, except that they do not operate on internal clock, but they are incremented by an external event, right? So what is the meaning? So as I told you that timer will work on internal clock. That internal clock can have time base of 1 second. It can have time base of 0.01 second. It can have time base of 0.1 second also, right? And accordingly your accumulator will increment by 1. But in case of counters, our accumulator value will increment by 1 by external events. External events here means what? Again, you can take the example of that bottling plant. When that bottling plant is crossing the photosensors, right? Infrared sensors or photosensors, and then it will generate one pulse. One event will be created. So when bottle crossing the sensor, it will make one true to false transition, right? With that, it will increment the accumulator value by 1, right? Let us say we want to do the packing of 10 bottles, right? So in that case, we will use one counter with the preset value of 10. When 10 bottles passes through these sensors, after each and every bottle, your accumulator value will increment by 1. And once your accumulator value is equal to or greater than preset value, at that time, now in this case, done bit of counter will be set. So done bit of counter, once it is set, then what we will do. So 10 bottles are complete. We will complete the packing of those 10 bottles, and it will be in our packing store. Then again, your counter will start from 0. Again, 10 bottles will come. It will again pack the bottles, and it will be stored in the bottle. So in this way, basically, counter. In case of counters, your accumulator value will be incremented by 1 through some external event, not through internal clock. This is the basic difference between timers and counters, right? Then so here you can see that, for example, they may be used to count the number of times that a contact closes or opens, or we can use input switch also. If we will make one high to low transition, that will increment the value of counter by 1. Likewise, sensor, any you can say object is detected by the sensor, that will also increment the value by 1. Here that is the means contact closes or open. Then counters can be up counters or down counters or up down counters. Up counter, I have already given you the example. What is the example of up counter? Means we are counting the bottles for packing. It will be up counter, right? That will be on the conveyor side. Now we will see the working. So Up counter is denoted by CTU. CTU is the you can say symbol for up counter, and its address, file address is C5. In case of timers, the file address was T4. In case of counters, file address is C5, right? So uh, now preset value is 120. So in this case, after 120 false to true transitions, or off to on transitions, 120 times we have to make an input on and off. Then your accumulator value will reach 120, which is equal to preset value. At that time, done bit of your counter will be set. It will be high, and we can use that done bit to make any output on or off. So here you can see that the run transitions can be caused by event occurring in the program. That event can be from a parts traveling past a detector, or actuating a limit switch, or you can create it through your toggle switch. You can create it through your push button. So basically, you have to create the external event to make accumulator increment by 1. Then, when run conditions for CTU instructions have made false to true, it is already explained. Now it is in technical term. I was just explaining it with the help of example. Now here you can see that when run conditions for a CTU instruction have made a false to true transition, the accumulator value is incremented by 1 count. The accumulator value is retained when the run condition goes false again. Means when run condition goes on to off, accumulator value will be retained. It will not be reset. But in case of timers, T on, T off, it was reset. So in order to reset the counters, we need one more instruction, because if we make any input on and off, it will retain its value. So it is also retentive kind of instruction. So in order to basically reset the counter, we have to use one more instruction uh, for resetting the accumulator value, and that instruction is denoted by res instruction. And res instruction is nothing but it is the reset instruction, and it will have a same address. Let us say I am using counter C5 colon 1. So my reset instruction will have same address C5 colon 1, so that my controller it will sense that counter C5 colon 1 is need to be reset once this reset instruction is activated. Now next is counter down. How to denote this CTD? CTD is denoted by count down is denoted by CTD instruction. Now where is its application of this CTD instruction? Again, we can consider that same example. We can consider for up counter, we are counting the packing of bottles. Down counter, we can employ where all these bottles are stored. From where these bottles are coming, actual main store, there we can keep the down counter. Let us say initially there are 1000 bottles, and bottles are coming from there, and we are using one down counter. It will decrement by 1 with detection of each and every bottle. So once your accumulator value reaches 1000, it means that your now main store is empty. Now you need another lot of 1000 bottles for further basically processing. So at that point we will have down counter. It is basically calculating the bottles, how many bottles are remain in the store. If it is 0, then another lot of 1000 bottles will come. On case of your packing side, we are counting up counter. we are counting 10 bottles, 10, once it reaches 10, then we are going to pack the bottles with packing of 10. So in this way, basically, we can use counter up and counter down. Application may be different, so you can easily use it. So again, it will also increment the accumulator value by one false to true transition, means one off to on transition. The CTD is an instruction that counts false to true transition. Run transitions can be caused by events occurring in the program, such as, again, same thing, parts traveling past a detector or actuating a limit switch. When run conditions for a CTD instruction have made um, off to on transition, then accumulator value here in this case will be decremented by 1. Our accumulator value will be decremented by 1, and the accumulated counts are retained again when your run condition becomes false. So again, you need what? You need reset instruction to reset the counter. The accumulated count is retained until it is cleared by reset instruction, that is RES, and we have to use the same address, whatever address we have used for this CTD instruction. Let us say it is C5:2. Then our reset instruction is going to denote it as C5:2 for resetting. So this is the symbol for reset instruction. You can see RES. It can be used to reset timer also. Timer, which timer? RTO. RTO is also retentive kind of timer. So we can reset that timer using this RES instruction. We can also reset this timer T on timer with the help of RES. RES can be used here. Now you can see this RES instruction is used to reset the T on timer, RTO timer, CTU timer, and CTD timer. So this is the purpose of this reset instruction. And now some PLCs they are also having counter up down, right? In one, or we can use them separately. Another example I can give you, one more example. Let us say car parking system. In car parking system, let us say a parking lot is having space for 100 cars, right? We have one entry gate, we have one exit gate. So on the entry gate, we will have one up counter, right? And on the exit gate, we will have down counter, right? So up counter value will be reset 200, will be set to 100. So once there are 100 cars in the parking lot, it will basically not open the gate. Now, with the same address, I am using another down counter on the exit side, which has same value. Once one car is exiting from the exit door, then your accumulator value will decrement by 1. Your accumulator value will become 99. Now, from entry gate, one more car can be allowed to enter in the parking. So this is basically your automatic parking system. So depending upon the availability, we can program the counters, and if your parking lot is full, then it will not allow to enter any more car. If let us say 3-4 cars are going out from the exit gate, then accumulator value again it will go to 96, and we can allow 4 more cars to go inside the parking lot. So this is the example of counter, how it can be used in actual application in our nearby, you can say, areas. So now we will see the working. We will see the working of counters using lead sim and using RS logics. So first we will see the working of these counters on our LAD sim. So we are combining timer and counters here. We can see it's working. Let us see what is there. Now in LAD sim, how to use this counter. I am using one XIC instruction. Use one timer with preset value of 2, let us say. Use done bit to make any output on or off. Select one output. Use done bit of timer. Use another timer of 2 seconds. Now I am using done bit of my timer to, this is same program, means to 2 second on, 2 second off. Our timer will be on for 2 seconds, to off for 2 seconds. Now I will now this is continuous process. It is never ending. It is on off. But now I want to make it stop. Let us say after five on, 5 times output is on, then it should stop. If I want to make a project like that, so in that case, what I will do, I will use counter. Now this counter is going to count the on and off of our output 5. So now in this case, my output will be on and off for 5 times, and after 5 times it will not work. Earlier it was working continuously. Now after 5 transitions, my program will stop. So here I am using counter up, C1 up. After 5 times it will be stop. So you can see that counter values also you can check. Here you can see that accumulator value is 2 now on counter. Now accumulator value is 3 after third on. Now fourth time on it is 4. Now fifth time, whenever it is on, then our accumulator value is equal. Now your timer is not working. Now this on off operation is stopped. So without counter it was continuous. With counter we can stop it after number of counts, number of 5 counts. So in this way we can use this counter in our program to count the external event. So this on and off of our output, it is external event and it is used to increment the counter by 1. So this was in LAD sim. Now if we go for RS logics. First we will see counter up. So here we have to give the address. This is the extension of that on off program. We are using counter number C5 colon 1. For how many times you want this you want to make this output on, you have to give that value. Again we are selecting 5. After 5 times on, it should be off program. It should not be continuous now. It is similar to earlier. Here we have to select the uh, here we are just giving independent working of the counter. We are using another input 2, and by making transitions, and we are using this done bit of counter, and we can make any output high after 5 on and off of input 2. Make it 2. Now we can download or we can save it. Now it is separate program. Last 2 rungs. We will work on last 2 rungs. Save it to any location. Now our that program is here. Download it to the Micrologics processor. Now we are ready for run mode. Go to run mode. Now make 5 on to off transitions, and after 5 on to off transition, here you can see that accumulator value is incrementing by now 2. Next time, now it is 3. Once it reaches 5, this output will be high. Now 4. Now 5. So once it is 5, then your output is high. So in this way, our counter can work independently. Now we will just use this counter to stop the continuous process, which is on the top, first 3 rungs. Now here we are going to stop the continuous process in this. Now I will use output O, this one, to make the transitions, and done bit will be used here with NC, done bit of this counter. Here now you can see that we have to make this. Delete this one. Now we can delete this run. Now our program is ready. We can save it. Download and then go online. So after this one, now our this output, continuous output transition, it will stop after 5 on. Here you can see that counter is incrementing 2, 3, 4 and 5. After that it should stop. Now this continuous movement of on and off is stopped with the help of this counter by counting the 5 external events. So in this way basically we can use timers and counters simultaneously in case of LAD sim and in case of our RS logics. So these demos we have seen. Now conclusion. Basically timers are used to count timer interval of internal clock. Counters are used to count external events, and some these you can say PLCs, they have sequencers also. So they are also very important, and sequencers can be time driven or event driven. So this is the conclusion, and with this these are the references for this whole presentation.